In Activity 7, Gears, students investigate a special type of wheel called a gear. Students first examine the structure of a gear, then observe how gears interact to transfer force, and finally discuss gear ratio. You will need the following materials from the kit: Activity Sheet 7, gear bases, gear handles, gear pointers, large gears, medium gears, small gears, gear cover, long rubber band, and a roll of masking tape. You will also need to provide pencils. To prepare for the activity, make a copy of Activity Sheet 7 for each student. Arrange a gear system for demonstration purposes using materials borrowed from one of the teams. First, place a small gear in hole D and a medium gear in hole J of a gear base. Then stretch a long rubber band around the gears. Make sure to position the cover on the base so that you can place the handle into the medium gear and the pointer into the small gear. Finally, tape the cover in place. Each team of 4 will need a gear base, a handle, a pointer, a large, medium, and small gear, and a pencil. To begin the activity, hold up the gear system that you assembled and turn the handle so that the students can observe the movement of the pointer. Ask, "What do you think is inside this system?" Accept all reasonable responses. When students have exhausted their ideas, remove the cover. Reattach the handle and pointer and show them how the system works by turning the handle again. Next, point to a gear and ask students what it looks like. Students should observe that it looks like a wheel. Ask students, how is it different from the wheel you just used in the previous activity? The students should notice that this wheel has teeth. Guide them to understand special wheels with teeth are called gears. Distribute a copy of Activity Sheet 7 to each student and the materials to each team of 4. Have the students count the number of teeth on the large, medium, and small gears and record these numbers on their activity sheets. Then, direct the students to put a small gear in hole D of the gear base. Ask students, how could you rotate this gear without putting the handle into it? To demonstrate, instruct students to put the large gear in hole G of the base and to insert the handle into the large gear and the pointer into the small gear. Explain to the class that the driving gear contains the handle and transmit force to the smaller gear, and that the driven gear with the pointer receives the force. Have the students turn the handle in the driving gear one full rotation in a clockwise direction and observe the movement of the driven gear and pointer. Ask students, in which direction did the driven gear turn? The student should reply that it turned counterclockwise. Then ask, how many rotations did the driven gear make? Students should have noticed that the driven gear made 3 rotations. Make sure students record their answers on their activity sheets. Next, ask students, why do you think the driven gear rotated 3 times for every rotation of the driving gear? Explain that because the smaller driven gear has 10 teeth and the larger driving gear has 30 teeth, the small gear will turn 3 times for every 1 turn of the large gear. Describe the relationship between the number of rotations of each gear as the gear ratio. The gear ratio in this example is 1 to 3. 1 turn of the large gear results in 3 turns of the small gear. If the small gear were the driving gear and the large gear were the driven gear, the ratio would be 3 to 1. 3 turns of the small gear would result in 1 turn of the large gear. A gear ratio is always stated as a ratio of the number of rotations of the driving gear to the number of rotations of the driven gear. Next, have the students insert a 3rd gear between the driving gear and the driven gear on their gear base. Ask students, were you able to obtain a different gear ratio by adding a 3rd gear in the middle? A student should say no. The ratio of driving gear to driven gear is the same whether a 3rd gear is placed between them or not. Next, ask, if the gear ratio stays the same, why add a 3rd gear between the driving gear and the driven gear? Explain that adding a 3rd gear allows the driving gear and the driven gear to rotate in the same direction. Then ask students, why did the 2 gears in the demonstration model turn in the same direction when the handle was rotated? Explain that the gears in the demonstration model turned in the same direction because the teeth of the gears did not mesh, but instead were connected by a rubber band. Finally, have students use their gear parts to help them complete their activity sheets. Offer guidance as needed and then review their answers as a class. To conclude the activity, have students dismantle their gear systems and return the components to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.